Hi everyone, welcome to this class where we'll be looking at the Thales Theorem. It's also known as the Basic Proportionality Theorem. So let's understand what is this theorem. We'll also look at its converse and some important questions. And I'm going to make these maths concepts absolutely crystal clear for you. So let's go ahead and get started. Before we begin, I just want to say, do check out the other courses on our website. You know, we have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and do share it out with your friends. So what is Thales Theorem? Please remember, Thales Theorem is also known as Basic Proportionality Theorem. And if you want to understand in a simple way, what does this theorem say? That if you have a triangle, okay, and you draw a line parallel to one of the sides of the triangle. So let's say we draw a line DE parallel to this side. Now it need not always be the base here. In this case it's looking like the base. It can be to any side of the triangle. So here DE is drawn parallel to this side BC. Then this theorem says that it will intersect the triangle at these two distinct points. This line which is parallel at D and E in such a way that these two sides, the AD and AC side, is divided by this parallel line in the same ratio. So please read the theorem and let's understand it. If a line is drawn parallel, so line basically means here the line DE. If a line, so for example here the line DE is drawn parallel to one of the sides BC. So clearly you can see DE is parallel to the side BC and it is intersecting the other two sides at distinct points D and E. So can you guys see the distinct points here? D and E. The distinct points here are D and E. Then the other two sides means not the side which is parallel, we are not talking about BC, the other two sides AB and AC. So what sides are we talking about? AB and AC are divided by this parallel line in the same ratio. So what is the ratio part we are interested in? That means this AD is to DB, the ratio of AD is to this length DB is going to be equal to AE is to EC. Do you guys get the idea of what is the ratio here? So basically this theorem is saying if DE is parallel to BC, then AD divided by DB is going to be equal to AE divided by EC. This is basically Thales Theorem, or also known as Basic Proportionality Theorem. So you can just remember it with this simple diagram. If you draw this parallel line, you can see that this ratio of AD by DB is going to be equal to AE by EC. And ratio means the lengths of these sides. So let's say this is, so if you take an example here, let's say this length is 2 centimeter and this length is 4 centimeter. This length is, let's say, 3 centimeters and this length is 6 centimeters. Now when you've drawn this line DE parallel to BC, clearly you can see what is the ratio? AD is to DB. So in our example, AD is to DB is 2 by 4, which is half here. And similarly, AE is to EC is 3 by 6, which is again half. So can you guys see that it is being divided in the same ratio? This is exactly what is Thales Theorem or Basic Proportionality Theorem. What is the proof of Thales Theorem? So if you guys look at it intuitively, it seems to make sense. And we have done similar triangles also. So can you guys see that these two triangles are going to be similar to each other? How? If you take a common angle and then, you know, these angles are going to be corresponding angles. Even these are corresponding angles. So by AA or AAA, we know that ADE is going to be similar to ABC. So you can imagine that, yeah, things are going to be in proportion, but here we are not comparing ADs to the entire AB, we are saying ADs to DB. So it's a little different from similarity because we are saying ADs to DB is equal to AE is to EC. These parts that the parallel line is dividing, it is dividing this side AB into these two parts. These two parts are in the same ratio as these two parts. Clear? But let's not worry about similarity right now. But intuitively you can get that this seems to make sense. But the proof doesn't use similarity. There's a very interesting proof based on area of a triangle, which you're going to look at, that how will you prove Thales theorem using area of triangle concept. Let's take a look. So proof may look complicated when you see it first time, but if you go through it carefully, and I'm going to explain the trick to you, I think then you'll find it very simple. So again, see, this is the theorem we are trying to prove. So we have written the theorem, and again you start off with what is given. Given is the triangle ABC, and you can take any any line parallel to one of the sides. We have taken DE parallel to BC, so you guys can see we have taken DE parallel to BC here, and DE is intersecting AB at D and AC at this E. So these were the two distinct points. And obviously what do we need to prove? That AD by DB, so this is Thales theorem, AD by DB is equal to AE by EC. This is what we need to prove here. Now how will you prove this? Since we are going to use area of triangles, you know area of triangle, what is the formula? Do you guys remember? Area of triangle is half base multiplied by the height. And height in a triangle always means perpendicular height. You can't have a slanting height, right? So area of triangle always involves half base times perpendicular height. That means since we are using area of triangle, we are going to be using area of triangle concept, we need to draw some perpendiculars. Now we are interested in the area of this triangle, let's say ADE. So we will drop these perpendiculars from D to this line AE. So we have dropped a perpendicular here AM, and then we have constructed another perpendicular EN. So this is a very important step where you need to do these constructions. So draw these two perpendiculars DM and EN, which are perpendicular to AC and AB respectively, and also join DC and BE. So you can see the constructions are done here. Okay, so it's looking complicated that hey, we have added so many things here, but trust me, it's going to be really simple. Okay, so now what are we going to do? We are going to start off with proving with using the area of this top triangle ADE. So I want everybody to focus on this triangle on top, triangle ADE. What is area of triangle formula? You guys know it is half base into height. Now if you are looking at triangle ADE, what will be the area? Half base into height. So if I consider this as my base, if AD is my base, what is the height here? Clearly the perpendicular height is EN. Do you guys agree? This is going to be my H. So I can say area of triangle ADE is half times AD times the perpendicular height EN. Do you guys agree? Please see if this is clear to you. Area of triangle ADE is half times base multiplied by the height. So this half base into height, everybody is clear? Half base into height is the area of the top triangle. Now, since I am interested in the ratio of ADs to DB, now I am going to shift my attention to the triangle below. Which triangle I am talking about? Triangle DBE. So we are going to look at the area of this triangle, triangle DBE this time, this guy. So I am looking at this triangle. What will be the area of triangle DBE? So if you guys carefully take a look, so for this triangle, let's say DB is my base. If I make DB as the base, this length is not the same as this, I am just calling it B for base. What is the perpendicular height here? Please remember that perpendicular height need not be inside the triangle, it could lie outside. So do you guys agree, if you look at this triangle DBE, triangle DBE, if DB is the base, then the perpendicular height is EN. It is that same guy which is outside the triangle. So please visualize it like this. So if this is my triangle DBE, the perpendicular height can be outside. This is the height EN. Okay. So again I am going to substitute. The area of triangle DBE is going to be the base DB multiplied by the same perpendicular height EN. So if I take a ratio of area of these two triangles, the top triangle ADE divided by the area of triangle DBE, what am I going to end up with? I am going to get, I basically need to divide these two. This divided by this. So what's going to happen? En will get cancelled. If I do a division, this guy is going to get cancelled. So what will I get? AD by DB, and half will of course get cancelled. Clear? So if you are finding a ratio of the area of these two triangles, ADE and DBE, you can see half will get cancelled, En will get cancelled. So I am going to be left with AD divided by DB. And AD by DB is very important because this is what we are looking for in Thales theorem. We have to prove AD by DB is equal to AE by EC. We have to prove that they are in the same ratio. So the main thing what we are doing here, we are looking for a ratio of area of triangle ADE divided by area of triangle DBE, these two triangles. So ADE, the top triangle, and this triangle. If you do the ratio of their areas, you will find half will get cancelled. The perpendicular height is same because the E is the vertex, so you're dropping the same perpendicular. So what you're left with is AD divided by DB. That's all you're left with. So that's great. Now let's take a look. If we do the same thing, but now on this side. So instead of considering that as the base, if we again look at our top triangle ADE, and this time consider AE as the base. So what will my perpendicular height be? This time it's going to be DM. So if I consider area of triangle ADE, then with AE as the base, the perpendicular height is going to be DM. This will be my height H. So what will be the area of the triangle ADE? Half times AE, this should not be EC, half times AE times DM. So you can see area of triangle is going to be half times AE times the perpendicular height DM. And what is the area of the triangle below that? That is the triangle DEC or ECD, whatever you want to call it. Area of triangle ECD, this time this will be the base and the perpendicular height is going to remain the same. If we are looking at triangle EDC, because this is the base and this is the perpendicular height same. So triangle of area of triangle ECD is going to be half times the same perpendicular height DM, but this time the base is EC for the lower triangle. So again, if you divide, what's going to happen? Half will get cancelled. If you find the ratio of area of these two triangles, half will get cancelled, DM will get cancelled. So we are left with AE divided by EC. And that's exactly what we want for Thales theorem. AE divided by EC. So now if we compare, so here what we have got, ratio of area of the two triangles AD by DB. Here we have got ratio of area of two triangles AE by AC. We need to prove that they are equal. Now for them to be equal, this area guys need to be equal. So what you can see here we have the same, in the numerator we have the same triangle, triangle ADE, and in this second equation also we have the same triangle ADE. But the denominators are different. Here we have triangle DBE, which means we looked at this triangle, the one on the left, and here we have the triangle ECD, the one on the right. But if you guys carefully look at these two triangles, DBE and DEC, or what did we call it, ECD, can you guys tell me what is the area of these two triangles? Are they equal or not? So again I am saying triangle DBE and triangle ECD, do they have same area? The answer is yes. Why? Look carefully. If you consider now ED as the base, if you consider the common base, you can see that both triangles have the same perpendicular height. If you consider this as the base, both the triangles have the same perpendicular height because they are between parallel lines. So clearly we can see that these two triangles between the parallel lines and formed by these dotted lines are having equal area. So therefore what can we say? That triangle DBE and ECD are on the same base and between parallel lines. so their area is going to be same. DBE and ECD have the same area. So the denominators are same. So that means area of ADE by DBE is going to be same as area of ADE by ECD. Since denominators are same, therefore we can clearly get AD by DB is equal to AE by EC, and so we have proved the Thales theorem. Thales theorem could also be proved using similar triangles, but we did not use that approach. We used the area approach. It looked a little complicated because we were doing ratio of areas and we were considering a lot of triangles here, but in the end you saw that it all worked out same because these two triangles at the bottom have the same area. So this one and this guy here, both these triangles ended up having same area. So AD by DB is equal to AE by EC. We have proved the Thales theorem or the basic proportionality theorem. So please practice this proof. First time you see it, it looks complicated, but it is all working with the area half base into height, the area formula, and then considering the correct base and the correct perpendicular. That's it. Then just writing the ratios, you will get the answer. Now what are some interesting corollaries from the Thales theorem? So one important corollary is that if you have a triangle ADB like this, where you have DE parallel to BC and it intersects, the other two sides at these distinct points AD at D and E, then what we can say? By Thales theorem we saw that AD by DB is equal to AE by EC. Right? We talked about that this AD by DB, so this parallel line is dividing the two sides in the same ratio, is equal to AE by EC. But not only that, also AD, also AB. So either you take these two parts, AD by DB is equal to AE by EC, or you can take the whole line, AB divided by DB is going to be equal to AC, the entire length, divided by EC. Okay, and similarly you can take AB, this entire length, AB divided by AD, so this time you take only the top part, is going to be equal to AC divided by AE. That means not only you just take a ratio of these two parts, you can even take the full length and one part, they will all be in the same ratio. So all these ratios are going to be equal. And you guys can check that with an example. So for example, if you take, like we had taken, let's say this one was 2 centimeter, we had taken this as 4 centimeter, this one as 3 centimeter and 6 centimeter. So let's confirm. So if you confirm the first one, AD by DB, so what is AD by DB? We saw that is 2 by 4 will be equal to 3 by 6, AE by EC, because we know half is equal to half. So this ratio is correct. Now if you want to prove this one, AB by DB, what do we get here? AB is this entire length. That means you add it up, 2 plus 4. So I'm getting 6 divided by DB, 4. Needs to be equal to AC, the entire length is 6 plus 3, 9, divided by EC, which is 6. And now you guys can confirm and check, this is going to be 3 by 2, this is also going to be 3 by 2. There you go. And you can check the last one also. So basically you can take either just part of the side or the entire side, but again in the same corresponding way, right? So here if you take the full length AB, it's going to be 2 plus 4, 6, divided by just the top part now, 2. And this side is going to be AC, the entire length 6 plus 3, 9, divided by just the top part AE, which is 3. And if you guys check, both the 6 by 2 is 3, 9 by 3 is 3. So you can check with some simple example, you can see all these ratios, whether you take a part of it or the entire thing, they are all going to be equal. So here remember, you can remember this with this diagram, that if you take this entire length divided by just this part and this entire length divided by just the top part, they are going to be in the same ratio. So how do you prove this corollary? It's very easy, because by Thales theorem we know AD by DB is equal to AE by EC. Now what is the trick is, you add 1 to each side. So the trick of proving the corollary is adding 1 to the left and right hand side. When you do that, what happens? The denominator is going to be dB. So the numerator is going to become AD plus dB because the LCM is dB. So AD plus dB is what? If you guys take a look, AD plus dB is nothing but the entire side AB. So this whole thing, if you add it up, AD plus dB is nothing but AB. And similarly, AE plus EC is nothing but AC. So there you can see. So very simple. You start off with Thales theorem, just add 1 on both sides and you can easily prove the corollary. Similarly, you can prove the second corollary also. You start now not with AD by dB, you start with the reciprocals. TB by AD is equal to EC by AE. So you take the reciprocal this time. Now again you add 1. And now when you calculate, you're going to get the same thing. This entire length AB divided by AD, the top part, is going to be AC divided by AE. So very simple to prove it. You just add 1 on the left hand side, right hand side. In one case you start with the Thales theorem. In another one you start with the reciprocal of the Thales theorem. Done. How are we getting AB by AD? So see, we started with dB by AD. When you do plus 1, the LCM is AD. So this will go dB plus AD. Or you can think 1 is AD by AD. So the numerator is dB plus AD. Now look at the diagram. What is dB plus AD? This entire length AB. So I am replacing this dB plus AD with AB. Similarly, I am replacing AC plus AE with AC. Just simply adding it up. Now let's talk about the converse of Thales theorem. What is the meaning of converse? Converse means the opposite. It's like sort of reversing the theorem. So what do we say here? If a line divides any two sides of the triangle in the same ratio, that means this time what is given to you, let's say you have a line DE and it is dividing these two sides in the same ratio. So let's say this time this length is let's say 4 centimeter and this is 2 centimeter, and here we have something like 6 centimeter and 3 centimeter. So can you see the line DE is dividing both these sides in the same ratio, because what is AD by AD divided by DB is 4 by 2, which is 2, and similarly AE divided by EC is nothing but 6 by 3, which is again 2. So you can see both are being divided in the same ratio, which is 2:1. If this happens, then this means that the line that you have drawn DE is parallel to BC. So if this happens, then we know that DE is parallel to BC. In Thales theorem, what was it? It was opposite. It was given that DE is parallel to BC and we said that the ratios of these two sides are equal. Here it is opposite. The ratios are given equal. That means based on it, the line DE must be parallel to the line to this side BC. So is the converse or the opposite clear? Again, how do you prove the converse of Thales theorem? So proof is very interesting. Let's take a look. So first we'll write what is the converse that we have to prove. Again, we'll start off with the given triangle, and what is given to us? This is given that AD by DB is equal to AE by EC. What do we need to prove? That DE, this guy, DE is parallel to BC. Okay. We will try to prove this in a very interesting way by the technique known as contradiction. Contradiction means what? We will assume that it's not true and we'll prove that's not possible. So it's like we are contradicting ourselves. It's like saying, you know, like today is a Wednesday. No. Today is a Thursday. No, it's not a Thursday. It's a Wednesday. Sort of like contradicting yourself. So let's see what do we do here. So what we are going to do is we are going to say let DE is not parallel to BC. So we want to prove DE is parallel to BC, but we'll say no, DE is not parallel to BC. So this is called the contradiction technique. So what we want to prove, we are assuming it's false. So let DE is not parallel to BC. So if this is not parallel, we are going to say no, we are going to draw a line which is parallel. So we have drawn this random line DF and we are going to say let DF be parallel to BC. I know it looks crazy. DF doesn't look parallel to BC, but we're going to take it, right? So this is a crazy technique where we say we draw another line which is parallel to BC. Now if DF is parallel to BC, this side BC, that means I can apply Thales Theorem in it. What did Thales Theorem say? That the ratio of these two sides, so AD by DB, will equal to AF by FC. I can apply Thales Theorem because I drew this magical parallel line. So it's like a Harry Potter line, right? We did this by magic, we have drawn another line, and we are saying by Thales Theorem, this ratio is true. But what is given to us? It is given that AD by DB is equal to AE by EC. This was what is given. So if you compare these guys, the left hand side is the same. AD by DB is AF by AC, AF by FC. Here AD by DB is AE by EC. So since the left hand side is same, I can therefore say AF by FC is equal to AE by EC. The right hand sides I am comparing. That means these guys are equal. AF by FC is equal to AE by EC. Clear? What we have done till now? Where we drew a line which was parallel to BC. So we will start with this. AF by FC is equal to AE by EC, and we'll do the same trick of adding 1 on both sides. Now when you add 1, something interesting happens. The numerator becomes AF by plus FC. What is AF plus FC? It is this entire side AC. Similarly here you get AE plus EC. So AE plus EC, so again you get the entire side AC. And now what's going to happen? This AC will cancel. AC means this side AC, not air conditioner. This entire side AC, and it's going to get cancelled. So what are we left with? FC is equal to EC. Now carefully look at our diagram. We are basically saying that this guy FC is equal to EC. If FC is equal to AC, this can only be possible if E and F are same. Yes, because how can FC equal to EC? It is only possible when E and F coincide. Only then this can be true. If they coincide, remember we said we had drawn DF parallel to BC. Now if these guys are the same point, F and E, that means since you drew DF parallel to BC, that means DE is also parallel to BC. And there we have proved the converse of Thales Theorem, that if the ratios are given equal, that means the line is basically DE is basically parallel to BC. So it is not DF, it is basically, since they are the same line, that means DE and BC are parallel to each other. So there we have done a lot of theorems, the theorem, the converse of Thales Theorem, corollaries. Now let's get into some exciting sums. Here's the first question. In the figure, DE is given parallel to BC. So whenever you see this kind of triangle where this, a line in the middle is parallel to this side, you know that this is probably going to use Thales Theorem or basic proportionality. And now what is given to you? That AD is given as 4x minus 3, AE is 8x minus 7. So all these lengths are given. You need to find the value of x. So how will you guys do it? Basically you will apply Thales Theorem. So we are going to say Thales Theorem or by basic proportionality theorem. By Thales Theorem, since DE is parallel to BC, based on this we know that AD divided by DB is equal to AE by EC. Yes, it will, this parallel line will divide the sides into equal ratios, right? AD by DB equal to AE by EC. Now just go ahead and substitute. So what will you substitute here? AD is given as 4x minus 3 divided by 3x minus 1, and that's equal to 8x minus 7 divided by 5x minus 3. Now how do you solve this equation? Because you have to solve for x. So one simple trick is to cross multiply. Since there is nothing much simplification we can do, so we can cross multiply here. So basically we'll get 4x minus 3 times 5x minus 3 equal to 8x minus 7 times 3x minus 1. Now I guess to solve this, you guys will have to expand out the left hand side, right hand side and see what equation you get, and please solve that equation. So can you guys do this for me? So please multiply out these numbers and this one and see what you get. So if you guys simplify, you will get something like 20x square minus 12x minus 15x plus 9, right? So you will get all these numbers here, and if you further simplify, you're going to get 4x square minus 2x minus 2, which you can divide by 2. So you're going to get 2x square minus x minus 1 equal to 0. What kind of equation is this? Quadratic equation, because it has x square. So you can solve it by middle term breaking, Sridhar Acharya formula, right? So always first try middle term breaking and see if you can easily solve it. And you look at the factors, 2 and minus 1 here. So if you break it into minus 2x plus x, you will easily get these factors of x minus 1 times 2x plus 1 equal to 0. So either x minus 1 is 0 or 2x plus 1 is 0, which basically means either x is equal to 1 or x equals minus half. So let me write this again since it's not clearly visible. So either x is equal to 1 or 2x plus 1 is 0, which means x is minus half. Now why do we say minus half is not possible? Can you have two answers for x? But minus half is not possible. Why minus half is not possible? Because if you go and substitute minus half, what will you get? 4 times minus half is minus 2, minus 3. So we are getting a length of minus 5. That doesn't make sense. And same for the other cases. So this is not possible because this will give us negative lengths. So the only answer possible, therefore, x is equal to 1 is the final answer. So that's the only answer which is possible here. And you guys can substitute back and check. 4 minus 3, so if x is 1, 4 minus 3, that means this is 1, this is 3 minus 1, this is 2, 8 minus 7, this is going to be 1, 5 minus, so 2. So there you can see the ratios are same, 1 is to 2, 1 is to 2. That means we have found the correct answer, and negative is not possible because it's going to give you negative lengths of these sides, AD, DB and so on. So always whenever you get a quadratic, you get multiple answers, please check if your answer makes sense. Here's the next question. P and Q are points on the sides DE and DF of DEF, right, this triangle, such that DP is 5 centimeters. So let's write down the values here. DP is given to be 5 centimeters. DQ is given as 6 centimeters. DE is 15. So this entire length DE and QF, this length is 18 centimeters. So I know this diagram is not drawn to scale, it's a rough diagram because QF doesn't look 18, right? And this DE is 15, this entire length. So the question is PQ parallel to EF? What do you guys think? So one is you could use this, small side is to the big side, but Thales theorem might be simpler because we want to prove PQ is parallel to EF. If we just want to, calculate this is to this, that you can easily find out, because what is the length of P? 15 minus 5. So we can do that. The length of PE is going to be DE minus DP, which is nothing but 15 minus 5. So that's 10 centimeters. So we know that our length PE here is basically 10 centimeters. So now to prove that if PQ is parallel to EF, that means we are using converse of Thales, right? That if the sides are in equal ratio, then it's going to be parallel. So let's find the ratio. What is my ratio here? DP is to PE. So DP by PE is 5 by 10, which is basically half. And what is my other ratio here? DQ is to QF. The other ratio is DQ divided by QF is going to be 6 by 18, which is nothing but 1/3. So can you guys see the ratios are not equal? So we can see, therefore, DP is to PE is not equal to DQ is to QF. So I cannot apply converse of Thales. For converse of Thales, these ratios needed to be equal. Then we could confidently say that DQ is parallel to EF. So therefore the answer is going to be, therefore PQ is not parallel to the side EF, and this is the final answer. So see, that's how we do it. We find the ratios here, and you saw the ratios are 1/3 and half. So we can clearly say that they are going to be not parallel by converse of Thales theorem. Let's look at the next question. This is very interesting, where we have ABCD is a trapezium with AB parallel to DC, and E and F are points on non-parallel sides AD and BC, such that EF is parallel to AB. So clearly you can see here, AB is given parallel to DC in this trapezium, and it says that EF is parallel to AB. Now we know if EF is parallel to AB, that means EF will also be parallel to the other side DC. What do we need to show? That AE is to ED is equal to BF is to FC. So since you have all these guys parallel, can we simply say that this is true by Thales theorem? Is this going to be correct? Because can I simply say that the ratio of these parts are going to be equal to the ratio of these two parts? By Thales theorem, am I done? Yes or no? The answer is this is wrong. Why? Because reminding you that Thales theorem is for triangles. There is no triangle here. You are looking at a trapezium. So this is not correct. Thales theorem cannot be applied to trapeziums. So what do? Very simple. How about we break this trapezium or this quadrilateral into triangles? Because Thales theorem we can apply for triangles. So what you guys can do here? Go ahead and do a construction. Let's say join AC. So if you join the diagonals of the trapezium, so any one of the diagonal, you're basically breaking it into two parts. So there you can see. So what you'll be doing? Construction, where basically you join the diagonal AC. Now you can see you have nice two triangles, and here we know that AB is parallel to EF and EF is also parallel to DC. So you can write those points, they're all parallel. Now if you look, things become easy, because the ratio of AE is to ED. So let's say this meets, diagonal meets this guy at, what should we call it? Let's say this is EF, we can call this G. So that means AE is to ED is going to be equal to AG is to GC by Thales theorem, because you can see these two parallel lines. So now we can say by Thales theorem, if we are looking at triangle ADC, so in triangle ADC by Thales theorem, what do we know? AE is to ED, AE by ED is going to be equal to AG by GC. So this we know, the ratios of this is to this is going to be equal to this is to this. Now you focus on the other triangle, triangle ABC. In triangle ABC, again, this is parallel to this. So that you should definitely write that all these three sides are parallel. So now looking at triangle ABC, again by Thales theorem. So what do we have? We can say AG is to GC is equal to BF is to FC. There you go. So again we can say AG, so this side AG is to GC is equal to BF is to FC. Because you don't always have to start from the top, right? You can take this is to this equals this is to this. So there you go. Now you just equate these two. So we are going to equate 1 and 2. So from 1 and 2 we can clearly see AG is to GC is common part. So AE by ED will equal to BF by FC. So we can say from 1 and 2, AE by ED is going to be equal to BF by FC. There you go. We are done. Proved. So simple. So the whole trick was breaking it into two triangles, because you can't apply Thales theorem to a quadrilateral like a trapezium. So there you go. Okay, here we have labeled this point as M or whatever you want to call it. And there you can see the same proof using Thales theorem. You could also have used the diagonal DB. You will get the same thing. So there you can see using both the things, Thales theorem on both the triangles. So this is your triangle 1 and your triangle 2. You will get the same answer. Let's try another interesting question. in the figure DE is parallel to BC, AD is given 3 centimeters. So again in geometry, make sure you're marking everything here. So AD is 3 centimeter, AE is 2 centimeter. So this length is 2 centimeter. BD is 2 centimeter. So BD is 2 centimeter. DE is 6 centimeter. And what do we need to find? The length of BC. This is the unknown. So how do you guys plan to do this? And you have been given that DE is parallel to BC, that we have marked in the picture here. So can we find this side by applying Thales theorem? Can we say, this by this equals this by this, or how do we do it? Can we apply Thales theorem for this one? So Thales theorem, according to Thales theorem, we know that if this DE is parallel to BC, so by Thales theorem, we know that when you have DE parallel to BC, then AD is to DB, the ratio of AD by DB will equal to AE by EC, because this parallel line divides these parts into equal ratio. But the problem is we don't want to find the length EC, we want to find the length BC. So can we apply Thales theorem here? The answer is no. So here basically Thales theorem or basic proportionality theorem does not help. So what will you do here? So because to find Thales theorem doesn't help you find the length of the parallel side. It talks about the non-parallel side, right? The parallel line dividing the other two sides. So how do you solve this? So one simple trick you can do here, when you can't apply Thales theorem, again look back at the triangles, because now you're looking at what? Triangle ADE, and you might want to look at triangle ABC because you want to find the length BC. What do we know about these triangles? Since the lines are parallel, we know that this angle is equal to this angle by corresponding angles. Again, you have parallel lines, these angles are equal, and of course this angle is common, angle A. So we know that these two triangles, the top triangle ADE and the bottom triangle ABC, are similar. So when you can't apply Thales theorem, go to the similar triangles. So we can say that triangle ADE is similar to triangle ABC by AA or AAA. Angle criteria. So now once they are similar, you can find the ratio of the corresponding sides are equal. That will help you find the length of BC. So let's go ahead and do that. So since they are similar to each other, I can clearly say that AD, so the length AD is to the whole, the other bigger triangle AD by AB is equal to DE divided by BC. Corresponding parts of similar triangles are in the same ratio, right? These corresponding sides, they are in the same ratio. So this is what we do. Now you just go ahead and substitute the values here. Very simple. AD is 3 centimeters. AB is given to you. The whole length AB will be 3 plus 2. So carefully add it up. This is going to be 3 plus 2, which is 5. The length D is given to you 6 centimeters. So we'll substitute that. And we need to find the length BC. So please go ahead and solve this. So basically we are getting BC is 6 times 5 divided by 3, or BC equals 6 times 5 divided by 3, which is nothing but 10 centimeters. That's the final answer here. So there you can see that using this similar triangle. So what did we do? So since Thales theorem did not work, using similarity. So similar triangles came to the rescue here, since we wanted to find this side BC, and you can see you will get the answer very easily. And so see, by the AA criteria, you must show that the triangles are similar, and we got the same answer, 10 centimeters. So hope the Thales theorem or the basic proportionality theorem and its converse is crystal clear to you now, and we practiced some very interesting and important questions. And do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other subjects, do take them and do share it out with your friends. For ICSE students, once again, we have physics, chemistry, biology and maths for classes 8, 9 and 10. And if you want to learn coding, we have Python programming, we have Java coding. Both are great languages to learn computer programming. And we have physics and chemistry for the Cambridge IGCSE, which is the international board. So please do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. We also have a Hindi channel. It's called Manocha Academy Hindi. Do stay connected with Manocha Academy and keep learning.